Good morning, everybody, and welcome to this panel discussion that we have at University of Bristol. We're going to be having some great conversations over the next hour and a bit. My name is Reid. I'm the Innovation Lead at the Golden Valley Development up in Cheltenham, and it's my pleasure to chair this panel today. So this session will bring together a panel of world-class researchers with a variety of expertise to share some of the exciting developments in their areas of research and what their contribution has been towards such things as the smart city agenda and the possibilities that their research could contribute to this and the broader sustainability and resilience agenda for the future. And what I'm going to do before we start taking lots of questions, I'm going to I'll introduce each of the panelists one in turn and just give them an opportunity to make some initial remarks, and then we'll get on with the questions. And please do submit questions throughout the session. So firstly, I'd like to introduce Professor Awais Rashid. He's the head of Bristol Cybersecurity Group, which is part of the Academic Centre of Excellence in Cybersecurity Research. He's director of the National Research Centre on Privacy, Harm Reduction and Adversarial Influence Online, director of EPSRC's Central for Doctoral Training in Cybersecurity, and the principal investigator and editor-in-chief of the CyBOK, the Cybersecurity Body of Knowledge. Welcome, Awais. Can you just maybe give us a few introductory remarks on the topic of sustainability and the future of smart cities and the like?
Okay. Well, thank you. You've already done quite a bit of an introduction to myself, so it's very good to be here. The work that I do in collaboration with a large number of people within our group, so it's a team effort, is on security and privacy in large connected infrastructures. And if we can look around us, digital infrastructures are everywhere. And what we specifically look at addressing is issues of security, privacy, what we would think of as across the full stack. So we look at the fact that these are now cyber physical systems. So, when we talk about sort of water, power, autonomous driving, and so on, these are not just digital systems, they have a physical impact in the world. Software sits at the very heart of this digital infrastructure and really drives our digital fabric. I mean, we are having this conversation right now through software connected systems, right? And then, of course, these cyber physical systems and software do not live in isolation. They have complex intersections with humans, both regular users and adversaries. So we look at addressing these across the board. And I'll be talking more about this as we go through the discussion today.
Great, looking forward to that. Thank you very much, Awais. Next, we have Professor Dimitra Simeonidou. She's head of the Bristol Digital Futures Institute, Professor of High Performance Networks in the Department of Electrical and Electronic Engineering. She's a member of the High Performance Networks Group, member of Photonics, and also a member of the Cabot Institute for the Environment. Welcome, Dimitra. Some initial thoughts from you.
Thank you, Reid. So myself, my area of research is telecommunications and networks, and I spent the best part of the last 30 years working on telecoms, both in industry and, of course, the big part of it in academia. The last 7 years at the University of Bristol, I have spun out two companies. So I have this combined understanding between research challenges when we are looking at digital infrastructure, but also commercialization and actually market placement of telecom companies, of telecom technologies. So from my point of view, I'm a director of one research center here at Bristol, which you didn't mention, Reid, but this is the Smart Internet Lab, which brings together indeed all the technologies that you mentioned. So it brings together wireless technologies, optical technologies, hardware and software, cloud, and the increasing role that softwareization and cloudification plays in our digital infrastructure these days. But most importantly, we connect actually we connect our research with application sectors like smart cities, which is going to be one of the focus today, but also other sectors that are going through digital transformation like transport, manufacturing, logistics, and so on. Now, also in my role as co-director of the Digital Futures Institute, we realized that actually when we are creating and deploying digital infrastructures, considerations are not only technological, but also we have to take into account society and how with digital infrastructure we solve societal problems. So to what actually Awais also implied with his introduction, quite a lot of our problems are not technical, but socio-technical. And we're taking this opportunity within the Digital Futures Institute here at Bristol to address new ways for innovating in the digital space in the future.
No, that's great, Dimitra. Thank you. So we've got cyber physical things to think about. We've got socio-technical things to think about. Excellent. I'm going to move on now and introduce Professor Theo Tryfonas, Professor of Infrastructure Systems and Urban Innovation in the Department of Civil Engineering, and also a member of the Cabot Institute for the Environment. Welcome, Theo. What are your initial thoughts?
Very good morning from me as well. Pleasure to join you on the panel. Yes, I'm well, a computer scientist by background, working for many years with civil engineers and challenges within the physical infrastructure sector and how technology, from the perspective we discussed it here, networking security links with physical infrastructure assets and their management. So I work broadly, if you like, in this field in smart cities and in applications of the two worlds we're discussing, connectivity and data and its governance and the security issues it poses. It's an exciting time for the sector. There are a lot of innovations that facilitate infrastructure delivery, the future infrastructure that we now need, because our infrastructure has aged and there are many challenges in upgrading and delivering across the country. Infrastructure that meets the needs of people, and a lot of this these days comes through support, or if you like, the essential function of digital infrastructure as well. So we know the state of infrastructure assets, we can respond to challenges and so on. So I'm happy to be here and discuss further later on the things we've already mentioned about cyber physical systems, socio-technical approaches in this space and so on.
That's great. Thank you, Theo. And last but not least, I'd like to introduce a final panelist member, Professor Mark Beach. Mark is Professor of Radio Systems Engineering, again, in the Department of Electrical and Electronic Engineering. He's also a member of the Communication Systems and Networks Research Unit. Welcome, Mark. Your thoughts to get us started.
Well, thanks, Reid. Good morning, everyone. So I've been at Bristol's for some 30 years now, and during this time I've seen and contributed to a lot of the evolution of wireless and radio frequency technologies. And this goes back really to the days of when GPS started, and I was doing some work on smart antennas, and then we applied that work to cellular radio systems, so antennas that can point their beams in directions to improve network capacity. And like many things we do, in particular the work I've been doing with Dimitra, is we tend to take this to demonstrators and so on. So through an activity in Europe called Research into Advanced Communications, this was back in the 1990s. This is when we first demonstrated digital beamforming. So digital beamforming to effectively put two users on the same radio channel at the same time, doubling capacity. And that's really what was the forerunner that we know today, a system that we call MIMO, multiple input, multiple output, which is synonymous with Wi-Fi routers, 3G and 4G. And this has moved on to the field of this stuff called massive MIMO, where we have 50 to 100 antennas at a base station. So we've got this very aggressive form of this spatial multiplexing. So it's sort of a spatial multiplexing on steroids that gives this spectral efficiency increase between 10 to 20-fold. And this is one of the key things in 5G going into 6G networks. So I've been working on that, but more recently, my interest has been focused towards robust and resilient communications, looking at the problems of the wireless channel between the transmitter and the receiver being open to cyber attack. And I am the academic lead on a UK project through the Prosperity Partnership Scheme on secure Wireless Agile Network, SWAN, where we're working with industry and government partners, so Toshiba, Roke Manor and GCHQ, along with academics here at the university to actually look at the problems of the wireless bearer and security. So thank you, Reid.
No, thanks, Mark. Yeah, that's quite a really interesting arc of research there and sort of development. So to get us framing some of the terms and the thinking, I wonder if I could start with each of you to ask the question, what do we mean by the terms digital or smart infrastructure? We hear about smart cities and so on, but what would you mean by smart infrastructure? Mark, I'll start with you, just because you've been chatting first.
Okay, so to me, smart is where a communication system is adapting to user needs or changing radio conditions, and the digital bit is doing the smart control. So perhaps something which we've looked at is putting additional capacity into a sports stadium and being able to address the different needs of people. So some people want to do short messages, text, Snapchat, Twitter, as well as others might want to do video uploads from spectators. So something like Massive MIMO allows you to have this smart adaptation and effectively offering different grades of service to users. And as that goes forward, we're bringing things like machine learning. So the technology will be able to predict and actually react beforehand, rather than having a little bit of lag in terms of users' needs. So it's bringing the smartness into the infrastructure, hopefully for the benefits of the end users.
No, thanks for that. And I guess, we've landed on the word smart, but we could think of intelligent or, adaptive and so on. Dimitra, what would you say? What does smart infrastructure mean to you?
Yeah, I would continue to the same theme as Mark. So sometimes we confuse the term digital with the term smart. For me, smart is when physical infrastructure and digital infrastructure, they come together to drive decision making. So I would go beyond, just focusing on telecom. So you can think of physical infrastructure, for instance, transport, telecommunications infrastructure, energy, water. And then when we are thinking for digital, there are things like Internet of Things, for instance, networks, machine learning, data, and so on. So when those things come together to drive decision making is where we are making that magic, which we call smart or intelligent. I cannot imagine something that is smart that is not intelligent myself. So if we are looking at different sectors, actually smart infrastructure probably has different instantiations in each sector. But for me, always there are three key things. The one is actually the data management. So how you harvest, how you curate, how you store data. The second one is the sense making, data analytics, for instance. And the third one is the decision making, which is the key source for making it smart. Now, nothing of this can happen without a key enabler, and that's connectivity. And that is where our field, that Mark and myself working on connectivity and networks, is actually absolutely necessary as underpinning infrastructure to make anything smart.
No, that's really helpful, Dimitra. No, thank you for that. Theo, if I could turn to you, we've heard about smart infrastructure, intelligent infrastructure, decision making. What does smart infrastructure mean to you?
Well, I'm on the same page with Mark and Dimitra, so I will try to unconventionally define it what it will be in 10, 20 years. And a lot of, us or people who advocate smart solutions, they hope that will be the new normal, that in 10, 20 years, that those will be the technologies that we will use to that are now tested or they're implemented across cities, and that some of them or all of them will remain as the state of art and with the next way of doing things, in the same way that we've been managing infrastructure assets by sending people to do manual inspections, and we hope that by deploying smarter systems with perhaps video and leveraging on the connectivity and the advanced computational facilities we've got and cloud, to be able to do the same work with less people and more technology, maybe more accurate, maybe less error prone and more responsive. A lot of discussion can be done on that, but certainly there's a proposition that by using all this technology, we can improve the way we manage and deliver services. And so we hope that this will be the new normal in 10, 20 years when things will be more established and proliferated in society and accepted and fine-tuned and delivered in a way that deliver value.
That's really helpful. And I think that's starting us to move on into that next question, really, which is really about how digital infrastructure can address societal and business challenges. If I could move to Awais, maybe you may have some other reflections on digital infrastructure itself. You might want to just, if there's anything that adds to what the others have said, but then also maybe if you could start to outline what you think the sort of societal and business challenges that we might address with digital infrastructure. So
I think I'd like to ask the question slightly the other way around, because I think I am in a, I'm somewhat the odd one out in this panel, in the sense that I look at the challenges that digital infrastructures pose, rather than simply what they enable in terms of solving. And when we talk about smart infrastructures, we talk about the kind of things that Theo, Dimitra, and Mark are saying that bring great value. You know, they can improve connectivity, they can improve gathering business intelligence from systems, they can link just-in-time supply chains. And I would say that, you know, we talk about smart as something in the future, but it's here today. Right, you know, you go on to kind of online platforms. You know, you are getting more personalized services. You know, your utility provider is actually making decisions about sort of power loads based on what's coming out of smart metering infrastructures and things like that. But I think the question that we need to ask ourselves is as to what are the challenges that come from these new types of infrastructures. And something that Dimitra said, I think, you know, really is a nice way to think about it, is in the sense that they rely on data, they rely on analytics, and there is about sense making. And in all of these things, you would expect me to say this, you have to think about, you know, what does this do with regards to security and privacy of those whose data and information is actually flowing through these kind of systems. And the key thing that we have to think about is that as we talk about these smart infrastructures, we are talking about a scale that we have never seen before. So there is a scale of connectivity. When, you know, Theo talks about smart cities, you know, we are talking about massive level of connectivity across a range of services here. Okay, we are also, as a result, seeing a massive scale of complexity, not just in terms of the heterogeneity of the platforms and the systems that are there, but also the multiple stakeholders who are now engaged. So, you know, one organization doesn't own the smart city, right? And that leads to really interesting problems that we see. So you have a scale of attacks that you haven't seen before. Okay, so, you know, let's say you have smart refrigeration across the city. Now, all of a sudden, you can potentially know the habits of all the citizens in the city. So there's a big privacy challenge on a scale that you haven't seen before. But if you're an attacker and you can actually compromise smart refrigeration across a large area, you can actually overload the grid and bring the grid down, which actually has a massive impact on a key service to society. So I think it's these new challenges and the scale of that they have, and the impacts that come from them are really things that we need to think about. And you know, these are the kind of things that we are looking at within the cybersecurity research that we do.
No, that's really helpful. So what you're saying is that we can't just think about the benefits to society of these new digital infrastructures. We also at the same time have to think about some of the risks and the challenges, and you know, it's sort of two sides of the same coin, as it were. And what we're dealing with is much bigger than a smart city. We are talking about something that's hugely complex, heterogeneous, and so on. Great. So I think we've sort of grounded ourselves in the topic. I wonder if I could open up to the others just to give maybe some other benefits for society as well as challenges. Dimitra, do you want to maybe go next?
Yes, and I'm not going to repeat what Awais said, because I go back to the comment that actually digital is imposing both huge opportunity, but also a challenge. And of course, just some years ago, we used to talk about digital sectors. Now we have to admit that all sectors are digital. So it's really underpinning everything in our life and economy. It is very important. And we should think about that co-creational part. Digital, for instance, in our cities, that would make our city more efficient and more livable, but also what interventions are going to be doing is going to be, trusted and transparent. And actually citizens and businesses could live with this and not feel that they're in a big brother environment. The second example, smart manufacturing, we are working on Industry 4.0, on Industry 5.0. And when you are looking, manufacturing is a sector that is going through a huge digital transformation, but the problem is the skills. And you have a workforce that actually they're very much worried about their future. And if they are going to be left behind the opportunity, and of course you have the Brexit things happening and the Trump things happening, and I don't want to go political when things like this happen. So how, when we are making actually digital intervention and we go through a path of digital transformation, we are actually going to take the workforce, the citizens, the society with us and create a digital future together. This is an important thing that we are going to have always as a consideration when we are doing research and innovation.
So what you're saying is that there are lots of different societal benefits, not just about smart cities, in terms of making cities work better, but there's a manufacturing piece and there's lots of other potential benefits. And digital is just a part of the fabric now. That's really interesting.
What I'm saying is that we have to think the digital transformation problem holistically, because if we don't take the users, the citizens, the society, the businesses with us, with all the specific, requirements and considerations they have, then we may go the other side and create situations of divide, rather actually creating the opportunity that come with digital and smart.
That's really helpful. No, thank you for that, Dimitra. So holistically, the people as well as the services and the technology. Mark, did you want to come in and give some thoughts on challenges and benefits that we will have with smart infrastructure?
Yes. So I will start with, I suppose, a benefit of something that I've seen. So I've been involved in a collaborative project where we've enhanced wireless access for train passengers. So I think most of us are aware that cellular and mobile access on a train is very flaky over the sort of 19,000 miles of train track we have in the UK. So we got involved in putting a millimeter wave access from trackside to train, then using conventional Wi-Fi on board. And this went from a concept to a demonstrator, and it's been rolled out with the help of a Bristol-based SME called Blue Wireless. And first group have actually got this on the Isle of Wight at the moment as an operational system, and they're going to roll it out on their franchises. So this is great. We've got broadband connectivity on the move for both business and personal use, makes time more productive. And now we've got to think about, what about the security of this new digital connectivity that we've now provided? So great opportunity, has enhanced what digital can do and wireless connectivity can do, but you've then got to think we've got to protect the people using it and the businesses.
Thank you for that, Mark. We'll come to some questions from the audience in a little while. But I wanted to just maybe dig into a bit more of your research as the panel. What would you? So if I go to Theo first, what would you consider to be the major breakthroughs for digital infrastructure technologies, and how has your research contributed to advances in this area?
I mean, it's in terms of technologies as such, I work by nature of the space I'm active a lot with connected objects, IoT, if you want for buzzwords. So we do a lot of work in connected objects to the internet or otherwise, and look at the capabilities you can develop by having sensors and other instruments connected in a way that you can access them remotely and you can send them remotely via people or autonomous systems to monitor and maybe actuate situations across infrastructure assets. But I think a lot of the challenges come in how these things become meaningful in a context of use. How would somebody within infrastructure sector, in energy, in transportation, in water, would be able to use those technologies? And so part of our work in a national facility that I lead, the Urban Observatory under the UK Collaboratorium for Infrastructure in Cities, we look exactly at modes of collaboration with key stakeholders, all the way from the individual citizen who's concerned about collecting data from around their environment so that they can understand better changes in the city, all the way to third-party organizations that we collaborate so that we set up real-world testbeds to conduct interventions and experiments in a real-world environment in a way that we get out of the lab and we do things in the city as a testbed, as a living lab, by deploying technologies around IoT and sensors and collecting urban data that we can develop. The insights that Dimitra mentioned earlier about then helping decision making upon a reliant sort of evidence base. And so that's sort of area that we work a lot with colleagues around the university and external stakeholders to deliver on ways we can use that technology in ways that we will create testbeds and methods for collection and analysis of data that would deliver those kind of insights.
Yeah, that's great, Theo. Thank you for that. Dimitra, I wonder if you could mention what you think are the technological breakthroughs and the research you've been doing that's contributing to the advances.
Can I mention 3 technologies, please, just to show my age as well? Because I think those 3 are really what made, what brought digital infrastructure globally. And I would start with optical fiber. And optical fiber, it's a huge innovation, of course, happened decades ago, but it was actually developed here in the UK in Northern Labs in Harlow by a man called Charles Theo and his team, and he got a Nobel Prize. I was really lucky to meet Charles Theo because I was working the same company with him. And I was also lucky to lead the design of the first optical transatlantic link between UK and America. That was called TAT12, by the way. And optical fiber really formed the backbone of the global internet. Without fiber, we wouldn't have any of the things that we are doing right here now. So optical fiber first, my team still is working on optical networks under the High Performance Networks group. Fantastic work, and there is a lot is happening right now. So we're talking about petabit communications between sites and data centers and so on. The second one that I haven't contributed, but we cannot not mention it, is the smartphone. I mean, we wouldn't be anywhere in terms of communicating without the introduction of smartphones, and I'm sure it has become extension of our body and of our hands for sure. Now, taking advantage of smartphone, that is an area that Smart Internet Lab, Mark, myself, and our colleagues, it's 5G, cellular network, particular 5G, and I must say that the Bristol team, Smart Internet Lab, has really led 5G research in the UK. And of course, now we are actually starting our 6G journey. And this has been a step change, not only the way that people communicate, but things communicate. So huge densification of supporting, machine to machine communicator that of course is very relevant to Theo's work. And of course, making this huge transformation of all sector around us, autonomous cars, manufacturing, and all these other areas, digital creative and so on. 5G is a huge enabler there, and 6G is going to be even more so.
And what about smart sensors? I mean, presumably that's also part of the technology mix that enables the communications, because you know, my smartphone has multiple sensors on it.
Yeah, I didn't mention sensors because Theo made a huge statement about things and sensors. And actually, to make anything smart, you need that machine-to-machine communication. Just the research that Smart Internet Lab has done and is doing is really to scale up this environment in a coherent way. So being able to support and connect trillions of sensors, you know, under a single or over a single network infrastructure is what we are doing. And so it fits with other research happening within our faculty.
No, thank you, Dimitra. If I could move to Awais, what would you consider to be either the technologies that have been sort of game-changing in this space, or maybe actually tell us about your research, because I know you've got a slightly different perspective to the other panelists.
Okay, so no, I think this is a perfect point for me to come in, and I'm not going to disagree with what Dimitra and Theo have said. You know, these are the kind of various advances that have kind of provided a step change in what we do. However, I think one of the challenges has been that as a society and potentially also as scientists, we have not always been able to anticipate the issues that would come with regards to security and privacy. And if we talk about, Dimitra mentioned optical fiber and you know, the sort of the core internet linkage that in due course it provides, but we know that the core design of the internet protocols was designed for connectivity and accessibility rather than security being a core design consideration. So that's why we see the kind of problems of, you know, large scale denial of service attacks, because the DNS protocol is not built with security in mind, or the border gateway protocol is not built with security in mind. And I had the opportunity to actually work on analyzing the security and resilience of the internet backbone in Europe to try and actually understand as to not only where the vulnerabilities in these protocols exist, but where they align with kind of physical topologies to create new types of risks. But if we then fast forward from that and we talk about kind of smart devices and smart sensors and so on, these have opened up kind of huge things. You know, now, for example, if you are a power plant operator or a water treatment or water services operator, you can actually get real-time intelligence about loads, demands, and those kind of things. But again, these systems were not designed to be connected to the internet. So as a result, there is a lot of kind of these older protocols and devices. You don't change your railway infrastructure overnight, right? These are kind of massive systems. You know, they are in place for a long time, and you know, renewals take careful planning. So as a result, you have a high degree of kind of what you would call legacy technologies and systems, and as a result, there are kind of major security problems. But I think also we risk making the same mistakes again. So when Theo talks about IoT, you know, increasingly we hear the same kind of things. Things are being designed for connectivity rather than, you know, security as a core consideration. You know, the core networking stacks are, you know, have vulnerabilities in them and things like that. And I think that's really where our research focuses on this. So we run our own testbed. We run a water treatment plant in the lab. We run a manufacturing system in the lab, a small one, and a smart building environment and so on. And we do quite a lot of analysis of vulnerabilities as well as experimentally evaluating countermeasures. But going back to the point about citizens, we also have social scientists and, you know, in our team who actually go and study how people's risk perceptions are with regards to these systems, whether they are organizational decision makers or citizens, and then use that to enrich the core design of the systems that we are developing to make these systems more secure.
No, that's fascinating. I'm sort of interested in the economics of what drives the new technologies and how we can introduce, you know, security at the right stage. I've got a question from S. Foster. It was actually in response to one of Mark's comments, but I think it's also relevant with what you've just said, Awais. I'll just read it out. Regarding Mark's Blue Wireless example, interested in what the priority drivers were in developing the demonstrator that meant that security hasn't been thought about earlier, and how are users enabled to make informed decisions about using that connectivity. So I guess the more general question is, how can we embed security in our research and development of new technology from, you know, as early as possible? Awais, do you want to go first? And then, oh, Mark, you go first. Mark.
Yeah, I suppose it's developing a mindset, really, taking a leaf out of Awais' book in terms of the effectively the openings that you make, where people can effectively intrude your network and steal information and carry out various forms of attack. So just going back to the question, like the driver for the improving wireless connectivity on trains was actually getting that technology to work and provide the communications. And it's probably only more recently and stuff that I've been doing through the SWAN project that I've become much more aware of how vulnerable our communication systems can be, and the fact that RF, well, it's effectively an open attack surface that somebody can get in there. So it's a mindset that we've got to get our researchers at the moment into at the university, working with industry, and we are going to have to propagate that message down through our undergraduate programs. So as we build up some of these demonstrators and these penetration test beds, if we can find a way of getting that into our teaching and sharing that with our students, and develop a new mindset about thinking about information needs to be secure.
Thank you for that, Mark. Awais, did you want to add to that?
Yes, I think it's a really hard problem. That's where I want to start from. That, you know, we have had notions of security by design and privacy by design for a long time. Okay, but they start from the assumption often that you can anticipate all the potential uses of a system, and you know, Richard Owen, who's a colleague here at Bristol, if he were here, he would be talking about responsible innovation and actually, you know, doing some anticipatory thinking about, you know, what the potential uses and misuses could be. And I think we don't do enough of that at the beginning. And I think one of that is to really actually anticipating the potential uses or misuses of things. And in security and privacy, we call it threat modeling. You know, you do your threat modeling and understand what would happen. But then I think the other thing I really want to emphasize is that we have to stop thinking about things in isolation. We develop something and we think there is this thing, this sensor or this platform, and it's going to do. But actually, vulnerabilities arise not just in the core design of that, but when that interfaces with many other systems and intersects in many complex ways with people and organizations. Okay, and you know, you bet your bottom dollar, and I don't mean this in a negative way, people use technologies in ways we don't anticipate. Okay, and that's exactly the problem. We think we should stop designing for people like ourselves, and we should actually, going back to Dimitra's point, really engage people into the core design of these systems, the users, because then we will anticipate what the uses would be, where the threats will arise, okay, and potentially, you know, where the vulnerabilities might be. And I think it's that kind of, I'm sure it's music to Theo's ears, you know, that kind of systems thinking is what we need to bring in, rather than keep thinking about things and technologies in isolation.
No, thank you for that. I'd like to sort of pick up another question from Sophie Patterson, and maybe direct that to both Theo and Dimitra, one after the other. And I think it follows on from what you've just said, Awais. How does the panel think that social sciences can be embedded in areas of work and research to ensure that future cities work for everyone and that no one is left behind? So, yeah, what's the role of social sciences? How do we embed those into our research and development? Theo, if you go first, and then Dimitra.
Yeah, I mean, there's a lot of divisions that we create in terms of, you know, our convenience and managed knowledge that separate sciences into hardcore technical and social. I think that do not help. But in our case, there's a lot of context that is missing and creates parts of the disconnects that we're discussing about. If you just stick with a group of engineers who try to think of an innovative solution that people can use, if exactly they're not really aware of socioeconomic and political circumstances that may enable one solution in one context and make it not work in another, because of geography, cultural, political, other factors that may exist. So you may be looking at the same evidence, but depending on context, history, the interpretation may be different. So there is room for social science to help with interpretation, to help with contextualization, to provide the links with, we're talking about how to, put the citizen or key stakeholders in a position to, mention co-production and help co-design research. This is not necessarily something that can happen natively with people that are large. So there needs to be some kind of translation between and collaboration between technologies and engineers like us who will design a solution, and others will understand the implications for linking it to context of use and then taking it to them. So I think there are many ways that you can naturally collaborate with social scientists, both in terms of making sense of what can be sensed in terms of data collection and how this would translate into minds of different people, and in terms of thinking of viable policies or viable architectures of systems that would be in place and will bring the benefits that the innovator imagined in the first place, or some of them, and put them in context.
Thank you, Theo. I do want to come back to Awais in a bit, but Dimitra, did you have a thought about the social sciences and integrating them into the research?
I have so many thoughts about this. Actually, Bristol Digital Futures Institute is doing exactly that. And most of the classical work, or let's say cross-disciplinary work that's happening across computer science, engineering, and social sciences is more reflective work. So a digital intervention happens, and we are actually come together with our colleagues from social sciences to analyze, hey, what happened here? So we have to change the way that we innovate in the future. I think I mentioned this at the beginning. Our methodological approaches towards digital innovation, it has to actually incorporate an interdisciplinary approach. So getting engineers, computer science working at the same space, new kind of labs, socio-technical labs, where we are working with social scientists, humanities, our colleagues from psychology, really create that interdisciplinary team that actually that we are going to think from the beginning, not what we are creating in the technology space, but for whom we are creating this technology. This is becoming increasingly important. I mean, Awais talked about systems approach. Our systems approach should extend to the end users. So we have to start thinking about human-centric systems, where actually that would obviously increase the complexity, heterogeneity, and challenge, and therefore a lot of challenge go to Awais about cybersecurity, but our systems have to extend beyond technical systems. And actually BDFI is doing exactly this. We are creating these socio-technical labs that they're going to enable this co-creation of technologies across disciplines and across partnerships.
I wonder whether the new Golden Valley development could be a test bed for that. That would be amazing. I mean, the other thing, just reflecting, was thinking if you're an undergraduate or a postgrad doing a master's or a PhD, you're trying to get your research done, but you're not an expert. Maybe you're a computer scientist, or you don't really understand social science. How do we do this through the teaching program?
Well, I mean, this is the biggest issue. We have to break silos, and I know that Awais is doing some of this with some new schemes, quite a lot of this. But the thing is that, I mean, American universities, some of them, they got this right, or better than us, because I would like to see social scientists to learn how to code, and I would like to see actually our students taking courses on social science and humanities. So you change the thinking. Just from a personal reflection, my son came to me the other day and said, Mom, I want to do this university course, which is computer science and philosophy. And I said, that's perfect. Because actually we have actually to start bringing the disciplines together, and the thinking for us is too difficult because we came from a classical education. We are trying and we are struggling. The new generation should actually start bringing down these barriers from the high school stage, from the university stage. Let's create this kind of degrees. that actually, just incorporate that cross-disciplinary thinking from the very beginning.
Brilliant, thank you, Dimitra. Awais, I know you want to come in on this.
Okay, so I think Dimitra has already said quite a lot of what I was going to say, but I think the key thing is that we have to shift this perspective. Okay, we have to stop thinking that infrastructures are technical only, and as a result, what we do, and we do this today, right? We look at them as socio-technical infrastructures. So as a group, we are interdisciplinary. We are based in a faculty of engineering, but we have social scientists, we have criminologists, we have social scientists from broad backgrounds, so from sociology, psychology, things like responsible innovation and those kind of backgrounds. And we tackle these problems together. And to going back to your question about sort of training, that's what our Center for Doctoral Training does. People come from many different backgrounds, and the purpose isn't to turn social scientists into computer scientists or the other way around. It's about actually providing people with enough understanding of the other disciplines so that they can actually engage and work on these joint problems, and bring their own perspective. There are two quick things that I wanted to note. I think one is we have to stop seeing other disciplines as a kind of just a methodological stake. Okay, that's problematic, right? So I think we have to really not think that social sciences are going to bring knowledge of humans and we can now incorporate them into our systems. I think we really have to think, how do we actually genuinely bring the different perspectives together to build blueprints of new types of systems from our perspective that are, provide increased security and privacy. Okay, and I think the other key thing that we really have to bear in mind is that, ultimately, what you want is people to learn other methodologies. And what I'm really proud of is that the computer scientists and engineers in our team, they are now starting to do grounded theory and those kind of things, which are typically social sciences methodologies. And social scientists are more engaging with, for example, learning more about how attacks happen against infrastructures and how they're exploited and so on, and use that in their research. And this ability to move across boundaries without leaving your core knowledge is key, but it only happens if we think that all disciplines bring valuable things. They're not just a methodological stick.
That's very exciting. Well, I mean, it sounds like, there's a lot of integration going on. Brilliant. I would love us to sort of move on to another question and to really start bringing in, I suppose, the consideration of sustainability along with security. What would what does the panel think are the main drivers and barriers regarding achieving sustainability and cybersecurity, as we move to digital transformation? Maybe if I could start, Mark, with you.
Yeah, sure. So I suppose in terms of sustainability, we've got to think about energy utilization and also the waste of precious materials as our digital consumer products that we like to continuously upgrade, and we just dispose of the previous model. So there is certainly much we can do to reduce energy consumption of sort of the RFE bits in wireless transceivers, and we certainly need to make radios more frequency agile, and that helps address some of these upgrade issues. And I suppose it's where we've got to have a mindset change in the way things are designed. So there has been some work at Bristol on waveform cancellation rather than conventional filtering for duplexers. And that type of thing would allow you to change bands a lot more on the fly as new spectrum becomes available. So that would address effectively throwing products away, and that deals with some part of the connectivity, but not necessarily the apps and the processing bang that you've got on a device, which I suppose is where we may need to use edge computing more, which Dimitra is a much stronger expert in that field than I am, to talk about how you might offload the processing, and that might stop with us throwing away products.
So what you're saying is that we need to build in sustainability as a mindset, as a set of values in the way that we research and design and deploy products. I wonder also if there's something about using the new infrastructure for sustainability, in terms of to work out where the problems are, as well as actually to build, in sustainability into the products themselves. Theo, do you want to come in on that at all?
Yeah, certainly. One of the big appeals of smart infrastructure, so to speak, at large scale for the physical assets of infrastructure, not the digital infrastructure we're discussing, but for bridges and roads and the assets of our physical infrastructure, is exactly that real-time and ubiquitous connectivity and real-time monitoring bring that ability to be able to measure and to be able to respond by, say, proactively maintaining assets in a way that would reduce carbon emissions, manage traffic, leverage on all the things you can optimize from an efficiency perspective. Of course, then you move into the territory that Awais was saying earlier. You might have a great energy system that tells you about loads to the finest degree, so you can tell when people are having a cup of tea and whether you want that or not. So you have to design a system pretty much as we're converging globally into having intermediaries that will handle the data and negotiate, under a strict legal framework how this happens. But the appeal really for larger scale infrastructure, or of the infrastructure we're discussing here, digital infrastructure, is that by embedding it into the physical asset, you're able to respond to the need for and adjusting for creating a more sustainable environment by regulating temperatures at the right level, by the built environment, for example, or managing traffic loads in a smarter way, and so on and so forth. So there's definitely a part of the drive we're discussing earlier, and the economic proposition maybe that pushes things forward without necessarily thinking of all the unintended consequences, is the fact, for example, the World Bank has conducted studies over the last 10-15 years looking at broadband penetration, and 10% penetration gives you up to 2.5 added GDP output, and of course that's huge and so significant that pushes forward with one development, one not necessarily bringing together along with it the concerns about security and privacy and so on, and there's space for that to happen as well. I think our current experience with going through a pandemic might sort of repurpose a little bit the need for infrastructure to have a longer view, not just sort of harnessing the economic benefits of the next few years, but taking a longer view that matches very well the sustainability outlook. Like, climate change and adaptation to that would only come if we look at the physical infrastructure as the pieces that they're here to stay for many decades, and we need to deliver to that time, values that we work with our time scale. It's unrealistic to try to extract value for satisfying shareholders for the next 6 months when the life of the asset is going to be 50, 100, 150 years. Think of Brunel's bridge that is with us 150 plus years. And at the same time, that gives us time then to work on the challenges on the side. Like, do we really want to know when people are having a cup of tea? Does it help us? And what kind of system we need to design so that we can have that information of the aggregate loads, but we don't have necessarily the view of when people are having a shower, if they have an electric shower, and so on. So I think there's an interface of the two that comes nicely when you start thinking exactly what we're discussing, the sort of systems thinking in the way and holistically that we mentioned earlier. And that alignment of purpose is key, and I think it can happen very nicely along all these goals for sustainable development and governance of data that would bring forward secure systems to the extent possible with respect to the individual and key stakeholders and the data, and deliver the value that we're talking about.
I mean, it sounds like, maybe thinking about sustainability and security as two separate silos is not that helpful, and we need to be more system thinking. And maybe if I can bring Dimitra in, I mean, there's a couple of questions or comments right at the beginning from Simon C on the concept of anti-fragility. I guess Nassim Nicholas Taleb's book, Anti-Fragile. I don't know whether, Dimitra, that's something that that concept is sort of you would recognize, and how do we look at sustainability and security as an overall system?
Yeah, I don't know if I would actually comment directly on anti-fragility, but I would go with the notion of systems level. So we mentioned this quite a few times, and we have to actually deal with this heterogeneity and complexity of systems. And for instance, if we take the issue of sustainability, we mostly address this, and it's quite right. You know, we address this, how I can make this piece of equipment or that piece of technology more energy efficient. And this is quite important, but it's like if we are saying, oh, if we introduce electric cars, our transport is going to be, you know, we're driving completely the net zero agenda in transport, which we know this is not true. So if you are actually making a system and which is very energy efficient, but you are running 1,000 AI algorithms in the background all the time, then actually your energy budget, you know, is going completely out of the window, and you move the problem from one part of the system to another part of the system. The same with security. I mean, we have to make combined sustainable and secure infrastructures. And we have actually to design systems end to end that they are going to comply to these principles. So just in danger that other people are not going to mention this, strategic targets and regulation, it is quite important actually to focus the mind. So the net zero strategy, which is both national and global, and actually goes down and reflects into sectors, for instance, telecoms, full net zero by 2050, by advocated by all our professional organizations and industry. It is a quite important target. In autumn, the UK government published the telecom security bill. Now, do we all agree with this? Probably we can start a different panel on that. But actually, it brings into the focus that there is a very strong, you know, driver to think about secure systems, not to design, you know, technology, 5G technology, and then think about the security risk or national security problems that they are exposed out of our 5G infrastructure. Is a single problem. And I would stop here because I'm sure Awais would comment on anti-fragility much better than myself.
And just before, thank you, Dimitra. Just before Awais comes in, I mean, we have a question, I think, related from Pradip Sharma. How will the activation of technologies such as quantum computing and 6G threaten digital infrastructures in the near future? So I suppose some of the technologies that are coming soon, you know, how will they actually threaten the future? And I don't know if that's related to
I'm not sure if it's threaten or an opportunity to go exactly to do what we pledge, system-based approach, think, combine the problem from the beginning. For me, and this is a personal view, actually quantum security and quantum computing is going to play a big role in future telecom systems. We are already seeing, for instance, being adopted in terrestrial fiber systems. We are already being adopted in satellite systems. So it's just a step. We can have converged quantum secure networks very soon. We see the emergence of quantum internet, which is really very much the story around interconnected computational resources, internet-like. We know that Google is actually piloting quantum data center services. They are coming. And it's not a case that we are going to move from classical security to quantum security, but we have to see the opportunity, you know, holistically to bring all the assets, technologies, all the breakthroughs that are coming in the future under this umbrella of sustainability and security. It's very important actually to think like this and utilize all this wonderful technology that we are developing in our labs actually.
No, thank you, Dimitra. Awais, would you like to comment on that, on quantum technologies and maybe also the anti-fragile?
Okay, that's a lot to follow, I have to say. Okay, I think I will briefly comment on the quantum technologies because I think this is a really good example of anticipating where the challenges are going to come from. And there are, you know, a number of colleagues. I'm not a cryptographer, but a number of colleagues, including, for example, Chloe Marsendale here at Bristol, working on post-quantum cryptography techniques to try and really understand, when quantum computing comes to pass and existing cryptographic algorithms will not be fit for purpose, can we have schemes already in place that would actually deliver, strong performance and strong assurances with regards to confidentiality, integrity, and availability, and so on. I think going back to the point about anti-fragility, I think this is a really interesting comment because I'm certainly aware of the same author's work on the black swan quite well as well. I think the key is that we are already in that space where our infrastructures are connected, and the infrastructures that really service society. You can't simply shut the system down because one of the hosts or computers, or so one of the parts of the system is actually compromised. So take smart city as an example. You're not going to shut the whole smart city down because a set of traffic lights is compromised. So then the key question becomes is, how do you actually gain security and privacy assurances that the system provides when it's in a partially compromised state? Okay, can you actually know that it's okay for you to continue to operate it in a safe fashion? And when do you actually bring it back to full capacity? Now, the whole anti-fragility concept is that, of course, systems learn from the chaos that comes, and they actually then improve themselves rather than just coming back to a stable state. And this whole area of actually adapting the system's behavior and self-learning and so on and so forth has been around in other forms, certainly in engineering fields. And the biggest question that comes from a cybersecurity perspective is that, yes, it can be a leverage to provide improved security, but it serves the dual purpose of actually increasing the attack surface of the system as well. Because now if you have a system that is adaptive and has that kind of learning built into it, how do you actually, and I go back to that point about how do you gain assurances that that adaptation is actually in a sort of in line with the kind of security and privacy assurances that you want? Okay, we all know what happened to the kind of Microsoft bot, that was online and turned racist because people could. And there are those kind of attacks against systems exist on a regular basis. Whenever you have a degree of autonomy in the system, it provides an other attack point, but also a potentially really powerful point. Because now, as a security researcher, and we go back to this thing about doing threat modeling in your head always, as a security researcher, I don't have to go and think about finding a vulnerability. I actually just have to make the system think that something is wrong or something has happened, and then it adapts itself to do what I need it to do, and so on. And these are the kind of things that people within the security community are studying. There are approaches under the umbrella of moving target defense that look at some of these issues and so on. They're not exactly called anti-fragility, but there is quite a lot of work on kind of autonomous security systems and the implications they bring, but also the value they provide.
Lovely. We could really press into that if we had time. We've got 10 minutes left. I wanted us to start thinking more about the future. So, what could change fundamentally over the next 20 years to enable more resilience and sustainability in the context of digital infrastructure? And maybe if I can start with Mark.
So I'm probably still thinking about new materials to get my frequency agility in and get the sustainability side up. And these things tend to be so much overlooked. So often if we want to make an antenna very broadband, it does tend to make it deaf, very insensitive, which means you end up turning the power up in a network. We just said we want to save energy. So that really does need to be addressed, the way that we design systems in terms of flexibility for the future, and also keeping their energy footprint and their sustainability footprint down. In terms of sort of wireless networks, in detection of cyber intrusion for a sort of IoT sensor system, it's going to be really low cost. We dare not put any more energy burden on the sensors. So we've got to find a way of actually doing that on the edge of the network, in the core of the network. So ways that we do that really does need to evolve.
Thank you. Theo, next 20 years?
I'll try to move outside my area and think of facilitators, catalysts that will help my area. And I'm thinking of the next 10, 20 years, thinking of planning and policy, and the way we experience the importance of digital infrastructures through the pandemic for our children accessing learning, for us working remotely, and so on. And of course, all the things that we've been discussing for longer, things like digital divide and so on, but were exacerbated, or at least they were tangible to many through this recent experience. I can see how in the next 10, 20 years, there won't be a discussion on if somebody wants to deliver infrastructure, the built environment, there isn't going to be planning regulation in place that will also ask of how this infrastructure asset is linked to digital infrastructures. That kind of integrated design happens well today at individual facility level. There's innovations like building information modeling, even early days for the architecture and civil and construction industries, but digital twins of individual buildings. But at larger scale, when there's a plan development and it's not a single stakeholder, it's not a campus that the university, for example, can deliver and design to the specifications we want, but there are many different contractors and many different developers and potential owners of a larger development. At the minute, within planning, there is not that thinking of how the connectivity will be in integrated fashion across every development, and also link it to the concerns we're discussing about compliance, regulation, privacy, GDPR, and so on. And maybe it's the next sort of, when the next planning laws are upgraded, they will have more elements of that. As we now can think of, how we'll design a building without connecting it to electricity grid and to water networks. Maybe the next iteration, the next 10, 20 years is about how we deliver infrastructure that is also connected, and with what ways and how it protects the data that is generated and it's necessary for its management and so on.
So maybe we need policymakers and planners in your research groups. Dimitra, the next 20 years, what would you say is coming?
What I hope is going to happen is break down what we see, the current existing model in terms of service provisioning and infrastructure, digital infrastructure providers, where it's dominated by big players. So the next 20 years, what I hope is going to happen is complete adoption of open infrastructure, open software platforms, complete commoditization of software, of hardware, not of software. Software is commoditized, but of hardware. So opening up the supply chain, really considering and encouraging ad hoc innovation, create new business models. So everybody, the community network, together with the service providers network, together with the private network, all part contributing to the same national or global infrastructure, completely new business model. So that democratization of digital infrastructure is the only way for me that is going to encourage innovation and that co-creational principles that we all discussed today.
Brilliant, thank you, Dimitra. And Awais, for you, what do you see coming in the next 20 years?
I think the short answer to that is, security and privacy integrated into all of that my colleagues have said. I think the slightly longer answer is, I think there are two key things. Okay, and the way I see it is that today what we've been talking about quite a lot is assurances, whether it's in terms of sustainability or security, privacy, or other properties. And Dimitra's example, you may be delivering a very kind of green solution, but if there is kind of piles of AI running behind it, it's costing a lot of energy. So I think the question is, how do we actually gain those end-to-end assurances? All the way down from the hardware through to the cyber physical environment, through software, through to people and organizations, and actually make sense of them, so that we actually understand that actually the system or the infrastructure is delivering the assurances with regards to net zero or privacy or security, that we expect as society. And we really need more integrated ways of doing that. And I hope that the kind of things that we are talking about here and the kind of systems thinking and interdisciplinary approaches are going to be key to that. And the second, and one thing that perhaps we have mentioned less of today, but we are in an academic institution, it's the people pipeline. Okay, and certainly there is a big shortage of people in cybersecurity, you know, and you know, there is estimates of kind of millions globally and so on. And I have no doubt similar issues exist in sustainability, but I'm not an expert in this. And I think that's really where the key is. We need to fix the people pipeline, because, you know, we need more people who actually are able to understand these problems from different disciplinary perspectives and actually then bring them together to address these problems. Because, you know, we also have to think about, you know, we shouldn't be playing catch up all the time. We need people who can anticipate these problems as they design new systems and tackle them into the core of the systems. And I think those are the two things I would say: assurances, end-to-end assurances, and the people pipeline in the next 20 years.
Brilliant. My final question, and it's going to be a quick fire round, is if you could wave a magic wand, what would you want to happen in the next few years? Mark.
Okay, what I'd like to see is the UK re-establishing its lead that we had back in the days of GSM and 2G. Effectively, we're really good at innovation. Okay, we need the people, Awais has mentioned that, but what we lack is the pull through to product. And let's see if we can get that back. Yes, we do need the innovators, but let's make sure the company rewards the end benefits as well.
Brilliant, thank you, Mark. Theo, quick answer.
I go back to what Dimitra mentioned about education that is more comprehensive, more holistic in nature, and teaches engineers about other things, rather just not solely our own discipline.
Brilliant. Dimitra?
Well, I'm taking out my magic wand, and what I would like to enact is an immersive internet and an internet of senses. So I would have liked right now to be together, you know, to merge that physical world with the digital world, to be together in the same rooms, to be able to have senses of touch, you know, complete immersiveness, senses of smell. So when we are having lockdowns like this now in the future, we still have that digital infrastructure that doesn't support only Zoom, but actually bring us together as close to reality as possible. And
Brilliant.
I hope that my research is going to make this happen, but not just yet.
Thank you, Dimitra. And finally, Awais, magic wand.
Security and privacy not being a negative story all the time. Security and privacy being the enabler of the kind of infrastructures that Dimitra talks about.
I completely agree. Well, thank you so much to all the panelists for a really stimulating conversation. We could have gone on, I'm sure, for at least another hour. And also thank you to the audience for attending and for the questions. I'm really sorry we couldn't answer all the questions, but really thought-provoking. And in the current climate, online is the only way that we've been able to do this. Maybe next time we can go to Dimitra's immersive lab. You know, I think we've done pretty well. And if what you've heard today or throughout the week has captured your interest, then please do get in touch with us at the Industrial Liaison Office. That's here to connect you to our academics and our students, and the contact details will be sent after this event. So thank you very much, and that's us a wrap.